Okay, we are beginning with set theory. Many of the things are aware because you have already learned them in 10th standard, but now we want to formalize everything that we have learned in set theory. Maybe prove a couple of theorems and go ahead with this background of set theory for learning functions and eventual calculus. So, first question that I should ask is, what is set? Can we define set? Write down your own meaning of set or definition of set in your notebook and read it. Okay. So sets are not supposed to be defined. I mean, if we start writing the definition of set, then we are wrong because this is the first thing that we are doing in set theory. So if we use words like collection or belonging to, etc., then we have to define those words also. And eventually, if you keep doing this, we will still be left with some English words which we cannot define, and therefore we will not get into that job and say that set is undefined. So set is undefined. Like in geometry, we had a few undefined terms: point, line, plane, etc. And the axiom, first axiom, postulate of set theory is existence of set. There exists set, or there exist sets. This is the first axiom of set theory. So we assume that we understand that what do we mean by set, we understand, but we don't want to get into defining it. And we understand that sets exist, and therefore we would like to use them without really proving the existence of sets. Sets are normally defined by capital letters ABC for set and small letters A, B, C for elements in the set. Okay. So if X is a member of A, we say X belongs to A. And we write in English because we don't want to write such a long English statement every time. We write in maths, X belongs to A. So if you read this much, it means we are talking about some set A and X is an element of that set A. X belongs to A. So that is what is the shortcut for expressing who is where. If Y is not a member of set A, we say Y does not belong to A. And we write it as Y does not belong to A. See the efficiency of mathematicians. Writing this much every time or writing this much every time is going to be time consuming and boring. Writing this is elegant and less time consuming. Moreover, those who do not understand this background will not understand this, and mathematicians want their notations to be understood by those who learn mathematics. So that is also achieved. That objective is also achieved. They make it so difficult to understand that only those who will study will understand. If they write it in English, everybody will understand. Those who understand English, everybody will understand mathematics. Mathematicians don't want everybody to understand mathematics. Therefore, they create, they say that it is very convenient notation, but sometimes it is so difficult to understand. Notation itself is so difficult to understand that people give up learning mathematics. Maybe that is what precisely the people want. And there should be teachers. Teachers should exist. They will explain the meanings of those notations to students, and things will be all right. Okay. Otherwise, you can use English words to explain all these things and everything. I mean, a set theory book otherwise would become 40-page book. If you write everything in English, it might become 100-page book. But okay, I mean, everything is going in recording, so I have to be very careful. Next, when do we say that two sets are equal? Equality of sets. I give you a chance. Can somebody tell me when can we say two sets are equal? Okay, two sets are equal if, as Shaurya said, that they must have same number of elements and all the elements in first set are present in the second and all the elements present in the second are present in the first. These are the same sets and maybe this is also same. Okay, so ordering inside set is not important. All elements, presence of all elements is important, and that is what it is. Understood? This example is very good because you can remember it. Any Maharashtrian student will remember this example very well and quickly. Okay, that is why it is created. There is no other intention. It gives you what do you mean by set? Is the ordering important or not? If you give importance to ordering, then these two things cannot be equal. But then curly bracket takes care of that. If it was a normal regular bracket, then it is order. Order and tuple, and ordering is important. In that case, that equality will not exist. Okay. So, next, let us now define subset. Subset. I want to say that A is subset of B. Sure. Now you have to use your skill. A is subset of B. Let A comma B be two sets. This is important. If they are not sets, then there is no question of one being subset of the other. So A comma B are sets, two sets, and A is said to be subset of B. If and only if, because we want it to be mathematical, all definitions are if and only if every member of A. This is important word. Maybe I write it in some other color. I have facility. Every member of A is also member of B. we write it as A is a subset of B. If and only if for every x belonging to A, x belongs to B. I really mean it. If suppose somebody reads this without the background that we had in last 15 minutes, he's not going to understand anything out of this. But actually it is very simple and everybody should understand, right? So if A is a subset of B, if and only if A is subset of B, if and only if for every x belonging to A, x belongs to B. That every is important, and this every in English here and every for all or for every in maths over here is going to be very useful to us. It carries a lot of importance. Okay. So if we say that A is subset of B, then we have defined successfully. Now let us define A is not subset of B. How will you define? Now write down your definition. A is not subset of B. Let A comma B be two sets. A is okay. Now we understand what we want to write. So let us write it in mathematical terms. A is not subset of B if and only if there exists. Now this fellow is yet another important fellow. There exists X belonging to A such that X does not belong to B. So this fellow is also important. Okay, A is not subset of B if and only if there exists. I mean, there is a meaning of at leastness in that particular symbol also. At least one element in A. There exists at least one element in A such that it is not element of B. It is not part of B. That is what is the definition of subset. And therefore, we wrote what do we mean by equality of two sets, but then when it comes to actually showing two sets are equal, we cannot have our English understanding of two sets. We need to have mathematical understanding or mathematical representation. So we can conclude by saying set A, let A and B be two sets. A equals B if and only if A is a subset of B and B is a subset of A. If this happens, this is very important. If this happens, then you can say set A and set B are equal. Okay. Write down the definition for A. Okay, let A comma B, A and B be two sets. A is a proper subset of B if and only if. Write down your definition. By proper subset, we mean, what do we mean by proper subset? We should understand that. I mean, we are part of this universe, all of us. If we consider set of 11th standard students, then they are proper subset of the entire universe, etc. So, proper subset means there has to be a bigger set and some elements of that bigger set create another set, and then therefore we said that the another set is a proper subset of the bigger set. I mean, in English, if we want to just explain what do we mean by proper subset. So now you start telling, yes, maybe I think Shaurya had said this, so I write that definition like this: for every x belonging to A and x belonging to B, there exists y belonging to B such that y does not belong to A. So using these first two definitions, belongingness, I mean subset and not subset, he has created, which is correct. Is there any short way of explaining? I mean, I think I find this very good. A is a subset of B and B is not subset of A. But then we have not defined, we have defined not subset. Then A is a proper subset of B. You can write it by using part of first and part of second. Third, A is a subset of B. For being proper subset, it has to be subset. And there exists Y belonging to B such that Y does not belong to A. Using equality definition, we can say A is a subset of B and A is not equal to B. That means the otherwise condition. This is same as second. And maybe we can say fifth in English, A is subset of B and B has at least one element, one member not contained in A. Yes.
Sir, and fourth.
Okay, fourth condition correction, A subset of B and A not equal to B. That is equivalent to 7. Fifth way of saying is that there is at least one member in the second set which is not member of first set, and therefore A is a proper subset of B. I should have said this first. What do we mean by universal set? All objects under consideration, universal set. Normally denoted by letter U or capital X. What do we mean by empty set? Set which does not contain any element is empty set. Normally denoted by letter phi or two curly brackets without anything in between. This is what is a notation. True or false? Set A is a subset of universal set. Set A under consideration is subset of universal set. If the context is correct, then this is true. True in given context. True or false? Second question. Phi is subset of any set A. Always true. Empty set is a subset of A. Always true. So theorem. Phi is subset of A. Now you have to write a proof for this. Okay. Proof. Indirect method. If possible, let phi is not subset of A, which means there exists X belonging to phi such that X is not member of A. Contradiction to definition of empty set. Therefore, we don't have choice but to assume that this implies phi is subset of A. Simple. Let us do now algebra of sets. Intersection of sets let A and B be two sets. Intersection of A and B denoted by is defined as A intersection B. How do you want to define? Okay. Okay, so the definition of intersection of two sets is this is set builder form of writing the set. All those X such that X belongs to A and X belongs to B. And this and is important. The element must be in A and the element must be in B. Then that element will belong to A intersection B. Next, something similar. Union of sets. Let A and B be two sets. Union of A and B denoted by is defined as easy, all those X such that X belongs to A or X belongs to B. Now, see, in combinatorics, you have addition principle. The English word was or, and now in set theory, when the word or is there, it is union. And when in end of your 12th standard, you will learn logic. In that, the connective or connective is represented like this. Okay, so all these things are equivalent. Are they have similar meaning in different theories. This is combinatorics is addition, English is or, union. Addition means plus. I mean, if you want to have symbol, plus in combinatorics. Multiplication in combinatorics is same as and in English. It's same as intersection in set theory. It's same as and get, which we will use. So there is a similarity in this, so it is easy to remember. And the way I remember is this A is and of course and is multiplication, and then all these three guys look alike, upside down. Important. Next. Number of elements in set A is denoted by n of A, or sometimes absolute value of A, mod A. This is the notation for finite sets. Next, complement of set. Let A be a set and U be universal set. A dash, complement of set is denoted by A dash is equal to all those x such that what should be the condition on all those x? X belongs to U and x does not belong to. We call that set as complement of set A. Sometimes it is denoted by a complement. Okay, so now it's time to solve one problem. Question. In class of 100 students, 80 like math. 6 physics. Estimate number of students who like. both physics and maths. Okay. So using inclusion exclusion or using geometric diagram, we can solve this problem. This is universal set U. You have set one set which is M, maths, another set which is physics, and there is some intersection. So all the elements, total elements are 100. Maths you have 80 elements. Physics you have 60 elements. And you are supposed to estimate how many intersections. 80 plus 60 minus total 100 is minimum. They must be, these many must be in the intersection minimum, is equal to 40 minimum. However, these all 60 can go inside. I mean, this is the diagram for this. But you always can have all those who like physics, all of them like maths. This can be another case. So this is 60. This can be 60. So maximum is 60. Okay, so that is, I mean, it is not simple example. Unless and until you have complete understanding of this, you won't get the answer right. Now, second question in this I can ask is number of students who do not like either maths or physics. And the answer is 0 to 20. 0 to 20. नाही काय चाललंय हे कॉम्प्लिमेंट. Now in this case, in complement you can have 20 students outside because this is total 80 maths, this is physics. So 20 could be maximum those who don't like maths or physics outside. However, when you put 40 here, common, you have 40 here and you have 20 here, that makes it 100. So you don't have anybody here, 0. So number of students sitting outside both the circles, but in the universal set will range between 0 to 20. Okay, I think we are doing good. Now let us talk about intersection and union of n sets.
So won't it be complement of M union of P?
Yes, sir.
M united with P instead of M intersection.
I have not given any thought to it, but let me check. It is the complement of A union P, correct?
Good.
That is what we are doing it in Venn diagram.
Sir, either or आणि neither nor हे दोन्ही इक्वल असतं.
आयदर ऑर आणि नायदर नॉर ते लॉजिक मध्ये खरं आपण शिकणार आहे. त्याला एकाला कॉन्व्हर्स म्हणतात, एकाला नेगेशन म्हणतात, एकाला कॉन्ट्रा पॉझिटिव्ह म्हणतात. आता आपण त्याच्या इंग्लिश मिनिंग वरनं मॅथमॅटिकल मिनिंग काढूया आणि वी विल टेक केअर ऑफ दॅट. बट इन लॉजिक वी विल राईट डेफिनेशन्स ऑफ दॅट. कॉन्ट्रापॉझिटिव्ह, कॉन्व्हर्स आणि नेगेशन, अशा 3 टर्म्स आहेत. सांगेन पाहिजे त्याचे मिनिंग. इंटरसेक्शन ऑफ एन सेट्स. Let A1 B1, A1 A2, AN be n sets. Now intersection of n sets is written like this. Intersection, capital intersection, I goes from 1 to n, AI is equal to, in curly bracket, all those x belonging to AI now complete this, and similarly complete for union. This is intersection of sets and union of n sets written as union I goes from 1 to n, AI is equal to x belongs to AI, complete it. Now this is extremely important because we are supposed to prove few theorems after this where this understanding is going to be very, very useful. Supposed to stop recording. Then if you want to take the intersection of all n sets, then we write it intersection I goes from 1 to n AI is equal to all those x, all those elements which are present in every AI for each I between I1 to n. And when it comes to union, it is okay if it is present in 1. So at least one I goes from 1 to n. So it is union and intersection of n sets. Now, we have to write down the meaning of x does not belong to. Say union of I goes from 1 to n AI. Think about it. And meaning of x does not belong to intersection I goes from 1 to n AI. Okay, if x does not belong to union, that means x does not belong to A1, x does not belong to A2, x does not belong to A3, x does not belong to A4, all. It should not belong to any one of them. So x does not belong to union AI is all those x which does not belong to AI for every I. Now again, this word is important here. Compulsory for each I. When it goes to intersection, it will be all those x which does not belong to AI. If it is not in the intersection, it at least one. Okay, I think this is play pain. For each in case of intersection here, when it comes to belongingness, and at least one in case of union when it comes to belongingness, and for each for union when it comes for to not belonging to, and at least one for intersection when it comes to not belong to. They play. Okay. With this background, I have to give you De Morgan's laws to prove. D M capital. First part, first law. Union of I goes from 1 to n AI complement is equal to intersection of I goes from 1 to n A complement I. Do you understand this? You are taking complement of union is equal to intersection of complements. Complement of union is intersection of complements. Now you are supposed to prove this, and I give you sufficient time. Let x belongs to which implies x does not belong to union I goes from 1 to n ai. What does this mean? It means x does not belong to ai for at least one I sorry. 1 is less than equal to I is less than equal to n. That implies x belongs to ai complement for each I 1 less than equal to I less than equal to n. which means x belongs to intersection I goes from 1 to n ai dash. That is from this side to this side. This is from LHS to RHS. Let x belongs to intersection I goes from 1 to n ai dash. This is from RHS to LHS. It means x belongs to ai dash for each I 1 less than equal to I less than equal to n. Actually, these are the opposite direction only. This implies this. This implies x does not belong to ai for at least one I 1 less than equal to I less than equal to n, which means x does not belong to union I goes from 1 to n ai, which means x belongs to union I goes from 1 to n ai complement. Okay, so this is first part of De Morgan's law. Second law is what? Intersection I goes from 1 to n ai complement is equal to union I goes from 1 to n ai complement of intersection is union of complements. Now this should be easy for you. I give you 4 minutes to complete this. Now basically in the first proof, what we have done here is LHS. In the first part we proved LHS is subset of RHS. And in second part we proved RHS is subset of LHS. And therefore two sets are equal. Because for proving equality of two sets, we have to do this. LHS subset of RHS, RHS subset of LHS simultaneously. That is why we have to write the separate proofs of both the parts. Even if they are going exactly in opposite direction, still we have to write because we are showing equality of two sets. Okay, let me write and complete this. Second also, let x belongs to intersection I goes from 1 to n ai complement implies x belongs to complement implies x does not belong to intersection I goes from 1 to n ai, which means x does not belong to ai for each I 1 less than I less than n, which means x belongs to ai complement for at least one. Is that one is less than equal to I is less than, which means X belongs to union of I goes from 1 to n AI complement. This implies LHS is subset of RHS. Part 2, let X belong to union of I equals 1 to n AI complement implies X belongs to AI complement for at least one. I, 1 is less than I is less than n implies X does not belong to AI for each I 1 less than equal to I less than equal to n, which implies X does not belong to intersection I goes from 1 to n AI, which implies X belong to intersection I goes from 1 to n AI complement RHS, it's subset of LHS, therefore LHS equals RHS. Okay, so we have proved De Morgan's laws for union and intersection of n sets. Okay, we have 20 minutes, so we have prove one more property.
Sir,
Yes.
sir, in the first part, second line,
Okay, it seems there are a lot of corrections, so let me just write them again from the basic. Okay, X belongs to complement of union that is sitting here, and therefore X does not belong to X does not belong to union of all of them. That is correct. So X does not belong to AI for all I 1 is less than equal to I is less than equal to n. So therefore X belongs to AI complement for all I 1 less than equal to I less than equal to n. Therefore X belongs to intersection of all I goes from 1 to n AI complement. I think now it is correct. Therefore LHS is subset of RHS. Now let us write down the second part. Okay. If X belongs to intersection of all complements, that means X belongs to AI. What should we write? It is intersection. It is practically meaning of intersection that we are writing. X belongingness and intersection. Belongingness and intersection for all. Again, we have to write for all only. Is it right? If X belongs to intersection of AI complement, then X belongs to AI complement for all I's. 1 is less than I is less than n. That means X does not belong to AI. So negation here for all I is less than this, and that means X does not belong to union of X does not belong to union of AI for all I such that this, that means X belongs to complement of this. So it is for all for first, De Morgan's law, everywhere for all. And let us see what is there for the second. If X belongs to complement of intersection, that means X belong to intersection of all of them. This is correct. That means X does not belong to AI. So what is the word that we have used in the definition above? X does not belong to intersection is for at least one. Intersections of for and does not belong to for at least one I such that this, then that means X belongs to complement of AI for at least one message, then for X belongs to this. So I think all four places it will be at least one here. बघा बरोबर आहे का? ओके.
Yes.
हा बरोबर आहे का आता? म्हणून त्या सगळ्या डेफिनेशन्स वरती व्यवस्थित लिहिलेल्या होत्या. एनिवे